have reinitiated at 6:45. You can start it. It's already late.
Okay, okay.
Yeah.
So Bhumika, can you hear me now? She joined just now only. Okay.
Of course, maybe for first 15 to 20 minutes she will be on and off, but later on she will be settled down. You can start the session, sir.
Okay, okay, sir.
You can extend your time to till 8:40 or something, if
Yeah,
necessary.
I will complete it and then only I will close it.
Yeah, yeah. But make sure it is not too late.
Okay, sir.
Bhumika, the teacher.
Bhumika, as I am not using mobile, I can't see you. So maybe you are messaging. Right. Arnav. So let me start explaining about this connected motion. Right. So in previous session, you might have learned about rocket propulsion. That means you learned about how rocket will move, what will be the equation for it, and what type of the system that is. Tell me, Arnav, what? Right, tell me what type of system the rocket is.
Sir, it is variable mass system.
Very good. It is a variable mass system. Continuously, what happens? The mass will goes on changing. And why we need variable mass system? To give lot of thrust or lot of velocity. And maybe I told you to settle down satellite at some place in a space, we have to send it with a velocity which is equal to 11.2 kilometer per second. And giving that much of velocity is not possible with a system in which mass will be remaining constant. So that's why we are using variable mass system, and when variable mass system is there, continuously mass will goes on decreasing. When mass continuously goes on decreasing, what happens? Velocity can be increased. As you know that mass if decreases, inertia also will decrease, and when inertia decreases, velocity increases. Okay, now so let us learn about that continuation. And in that continuation, actually, what is our chapter? What is our chapter, Arnav?
Newton's law of motion.
Newton's laws of motion. That means we are learning about motion of an object, isn't it? And
Yes,
how
sir.
it will move, and when they are moving, what type of forces will be there, and if force is there, what will be the acceleration of it, what will be the tension of it. So like that, we are going to learn about all those things, isn't it? Now,
Yes, sir.
in a same manner, what we are doing today is we are learning about objects which are connected to each other. And when they are connected to each other, how they will move, which side force will be more, and in which side it is moving, how many forces are acting on it, and what will be the resultant acceleration, what will be the resultant tension. So like that we are going to discuss today. And maybe you are observing one diagram in the slide, and in that diagram how many masses are there, Arnav?
Two masses.
Two masses are there. One is m1 mass and other is, this is m1 mass and this is m2 mass, and these two are connected with some string actually. So this is a string, and these two are connected, two objects are connected with a string. And let us consider the string is a very flexible one, and which is not having very much mass actually. So it is a massless, frictionless one string actually, and that string is holding two objects by using one pulley. And maybe in diagram one pulley is also there. And let us consider here now whatever the system we are learning. In this system, let us consider m1 is greater than m2. That means mass of the first object is greater than the mass of the second object. So if mass of the first object is more and mass of the second object is less, tell me which side these connecting bodies will move, whether towards the mass m1 or whether toward the mass m2 down. Which side it will move?
Towards mass M1.
Towards mass M1. That means mass M1 will move down or move up.
The move towards Earth.
Right, move toward the earth. Very good. What about M2 then at the same time?
Sir, it will move in the opposite direction.
Opposite direction means upward or downward? In upward
Upwards.
direction or downward direction?
Upward.
Very good. So M1 mass is moving in downward direction, whereas M2 mass is moving upward direction. Now our aim is to calculate with what acceleration M1 and M2 are moving, both are moving. So that we have to find. And apart from finding it, we have to find out the tension which is there in this particular string. That also we have to find, and already one equation was given here. T is equal to 2 m1 m2 by m1 plus m2 into g. And how to derive it? If you understand how to derive this equation, then you can solve few questions which are there in our class today. Okay. And whenever you are dealing such kind of a problems or such kind of a explanation, generally always you have to think about one kind of a diagram, and that diagram generally we call it as free body diagram. What we have to say it as? Free body diagram. Free body diagram means what we say in that free body diagram. We say how many forces are acting in on that particular object and in which direction they are acting. So that will be known by drawing what? Free body diagram. And this is also whatever the diagram is there in your slide, that is also a type of a free body diagram. But now let us try to understand free body diagram of mass M1, free body diagram of mass M2, and let us write few equations and let us solve them and find out that relation. T is equal to 2 m1 m2 by m1 plus m2 into g. So let us find out it, and in order to find out it, let us first observe about mass M1, and see here mass M1 object is there, and free body diagram of mass M1 I am writing first. So free body diagram mass M1, and this is the mass M1 object. And tell me, on every object, acceleration due to gravity will work or it will not work? Acceleration due to gravity.
Sir, it will work.
Right. When acceleration due to gravity is acting on any object, definitely each object will be pulled towards the earth or not?
Yes, sir.
Right. What that pull of the earth will be called? What the pull of that earth will be called? Okay.
Acceleration due to gravity.
No, that is acceleration due to gravity, but I am asking pulling force.
Weight.
Very good. Weight. What do you mean by weight generally, Arnav?
Sir, the force with which the Earth pulls objects towards
Very
itself.
good. The force with which earth pulls all the object towards it. That will be called what? Weight of the object. So for every object, weight will act in which side? Downward direction or upward direction? Weight of the object always will work towards which side? Downward or
Downward
upward?
direction.
Huh?
Downward direction.
Very good. Downward direction. So always whenever you are drawing about free body diagram, you have to think about weight first, and weight generally will act in which direction? Downward direction, like this. So I am writing that weight as m1g, already you know. And this particular mass m1 object is attached to what? A string actually. And whenever string is there like this, which is attached to the another mass, definitely what will be there is, in this particular string some tensional force will act. What force will act? Some tensional force will act. Now what you do is you take a rope and you hold that rope at one end, and you ask your brother to hold that rope at other end tightly. Then if you pluck it, it will vibrate or not? If you pluck it, it will vibrate or not? Arnav? Arnav?
Yes, sir, it will vibrate.
And whenever you are holding like this, two sides you are holding some rope, in that some tensional force will be there or not? Some kind of a stiffness will be there for that rope or not?
Yes, sir.
So that stiffness force only will be called what? Tensional force actually. Now, as M2 mass is also dragging this particular M1 mass with some force, that's why tensional force will act in upward direction or downward direction now. Tensional force now,
Downward direction.
right? This particular object is holded by a string with another mass, and when it is holded like this, this M2 mass, whatever is there, this will pull this particular M1 object. So that's why tension will always act in upward direction in this case particularly. So here tensional force will act in upward direction from this center point. So tensional force. So how many forces are acting on this object? Now two forces are acting on this object, but due to these two forces, it is moving in which direction? Downward direction only. When it can move in a downward direction? When the resultant force is there along which direction? Downward direction. So let us think the net force acting on this mass M1 in downward direction is F, and F is equal to, can I write like this? M1 G minus T. Can I write like this? M1 G minus T. Now what you do is you take one object, and to one side Arnav is pulling it with 10 Newton force, and your brother is pulling that same box to the other side with a 8 Newton force. Which side it will move, Arnav?
Sir, I am pushing it with.
10 Newton. And
Sir,
your
it
brother
will move
is pushing
towards me.
with 8 Newton.
Sir, it will move towards me.
Very good. Why? Because you are applying more force than him actually. And here also, when object is moving down, what do you mean by it? More force is there towards the downside than the up one side, isn't it?
Yes, sir.
Like when two forces are acting in opposite direction like this, one is acting in this direction, one is acting in this direction, one is acting in this direction. When both are acting in opposite direction like this, what will be the resultant? Resultant will be the difference of those two forces. So whatever the two forces are there, and how much difference will be there, that difference you have to write. So the resultant force will act in downward direction, and that resultant force I am writing with F is equal to M1 G minus T. Why? Because M1G will be more than the tensional force. That's why only the object is moving down. Now maybe you know that according to Newton's second law of motion, F is equal to ma. Can we write it or not?
Yes, sir.
F is equal to ma, we can write. So then resultant force, can I write like this? M1A is equal to M1G minus T. Can I write like this?
Yes, sir.
Right. I am thinking it as equation number 1. Now similarly what I am doing is I am taking second object. Now I am taking M2 object. Now always you know that on M2 object also downward direction, definitely what will act? weight will act. And now tensional force
Is
will
great.
act on that string or not, which is attached to the M2 mass.
Yes, sir.
And that will act in which direction? Upward
Upward
direction.
direction.
Why upward
Towards
direction?
M2G.
Because M1 is pulling it. When M1 is pulling it, definitely upward direction. What will act? Tensional force will act. So tensional force is acting in upward direction. Now tell me, because of these two forces, which side the object is moving now? In a connected bodies, it is moving in upward direction. So when it is moving in upward direction, now tell me what you can write. Resultant force on second object F, you can write like this: T minus M2G. Can you write like this?
Yes, sir.
That means tensional force will be larger than the M2G. That's why only it is moving up. Or else F plus T is equal to M2G. You can write like that also. Right? So T minus M2G will be resultant force actually. Now how can I write equation similar to equation number 1? I can write like this: M2A is equal to T minus M2G. Can I write like this?
Yes, sir.
Right. Why I wrote M2A? Because the resultant force generally gives us MA according to Newton's second law of motion. That's why I wrote M2A is equal to T minus M2G, and I'm writing this as equation number 2. Now what I am doing is I'm adding equation number 1 plus equation number 2. When we are adding, left side values also we have to add, and right side values also we have to add. And if you add, tell me what happens. See, left side M1A is there. So M1A plus M2A is equal to. So now I am adding right side. M1G minus T plus T minus M2G. Now see here, minus T is there, plus T is there. These two will be cancelled. Now, if I take A common here, tell me what I can write. M1 plus M2 is equal to, if I take G common, what I can write? M1 minus M2 into G. And now tell me, from this particular equation, can I write like this? Tell me. A is equal to M1 minus M2 divided by M1 plus M2 into G. Can I write like this? Arnav?
Yes, sir.
Right. So when I write like this, now observe carefully, acceleration is equal to what we can write: M1 minus M2 by M1 plus M2 into G. This will be the equation for acceleration of both the objects. And now remember here, Arnav, when mass M1 is moving down with the same acceleration, what will move up? M2 will move up. With what acceleration M1 is moving down, with the same acceleration M2 will move up. That's why we are getting same value. A is equal to M1 minus
Yes.
M2 by M1 plus M2 into G. So as connected bodies is there, you will get only one acceleration, not two acceleration. One acceleration for one object, one acceleration for another object. As system contains two masses, so definitely these two masses combinedly will move with some acceleration, and that acceleration we found here. And again, tell me what is the equation for acceleration here? Acceleration A is equal to M1 minus M2 by M1 plus M2 into G. Isn't it? Is it right?
Excuse me, sir.
Tell me.
Sir, Sahas has also joined the meeting.
Okay. Now, Sahas, can you speak? Sahas, can you speak, or only he is in a listening mode?
Sir, he can speak.
Okay, Sahas wants to speak. Okay. What happened, Sahas? You are listening or not? Just now only he joined, or no?
Sir, it has been 10 minutes.
Okay, Bhumika, whether she joined?
No, sir.
Not yet.